Welcome to today's science lesson, and we shall continue. We are dealing with natural resources, and today we are continuing with air as a natural resource. Air as a natural resource. Yes, in our previous lesson, we had said that air is one of the major natural resources, and we said air is a renewable resource. And we said air contains a number of gases, and we shall try to know what are percentages of these other gases that form air. We are saying, what is air? We can define air as a mixture of gases and suspended particles such as dust, smoke, and water vapor. Of course, we have water vapor droplets. So once you take air and you want to know what air contains, you'll find that in this air it will contain mixture of gases, yes, and it will also have suspended particles of dust, suspended particles as dust, smoke, and water droplets. So if water exists in the form of a gas, then that water will exist in the form of a water vapor. Thank you. Now we are saying the main gases in air and their importance to life on Earth can be seen on the following table. Therefore, we are going to construct a table that is going to show the main gases that form air. And we shall see the importances of these gases in supporting human life. Therefore, we can have a small table. We can write gas and the percentage. Percentage in air. We want to know this gas, in what percentage does this particular gas exist in air, then importance to life. Also, we would like to know what is the importance of this particular gas in supporting life in organisms, life in human beings. We can have such table that will indicate when we are trying this, because in terms of percentage, the column of percentage needs to be thin as to compare to other columns. So the first gas we have here is nitrogen gas. So the first gas we have is nitrogen gas, and we are told it is present in the air. It is 78% present in air. So it comprises of 78%. And we would like to know what is the importance of this particular nitrogen gas. Does it have any value in air? Does it in any way support life in the atmosphere or on Earth? So we are told nitrogen provides nutrients for plants to make proteins and other chemicals. So we are saying provides nutrients for plants. Nitrogen is there, provides nutrients for plants So we are saying nitrogen provides nutrients for plants to make proteins. To make proteins. So we can see that plants use nitrogen to make proteins and other chemicals which humans and other animals can use as food. Which humans and other animals can use as food. And other animals can use as food. So we are seeing the main importance of having nitrogen that is present in the form of 78% in air. We are told it provides nutrients for plants to make proteins and other chemicals which humans and other animals can use as food. So we are seeing nitrogen is present in that percentage, that is 78% in air. Then we have oxygen. We can draw this line to ensure that we are through with that column. Then we have oxygen. And oxygen is present in 21%. So the percentage of the oxygen, the percentage that is there in air of oxygen is 21% present in the air. And what is the importance of this oxygen as far as life is supported? Is it important to life? Yes. This is what we are told about oxygen. We are told oxygen is used essentially for most living things. Essentially, oxygen is used for most living things. So most living things, most organisms do use oxygen for most living things to release energy from food. To release energy from food. Therefore, the living things, for them to be able to digest the food they have digested, the food they have within them, they require oxygen for them to enable them to digest that food properly, to get energy that is very important for their body function, to release energy from food for their bodies, energy from food for their bodies. For their bodies to use. So we are seeing that oxygen is very important to living things and of course humans as well, that they are able to digest the food they have taken in very well. When they use the oxygen they have, they will be able now to release energy from that food, and they will be able to support their body functions well. Now, from oxygen, then we go to another gas called carbon dioxide. And we are told about carbon dioxide is available in the air in such percentage 0.03%. That is the percentage the carbon dioxide is available in the air, 0.03. But we want to know, is this carbon dioxide important as far as life of living things is supported? Does it in any way support the existence of life in these living organisms or living things? Yes. We are told carbon dioxide is essentially there, important for plants, essential for plants to make their own food. Essentially for plants to make their own food. To make their own food. Therefore, we can see that plants are able to use carbon dioxide to make their own food by photosynthesis. And we know through the process of making their own food through photosynthesis, they are able to also to produce oxygen as a byproduct. And we know oxygen is important in supporting other living organisms, for instance, human beings and so forth. So we can see that with that small percentage of 0.03% of carbon dioxide, that is enough carbon dioxide that is required by plants, green plants, to manufacture their own food in the process of photosynthesis when it traps light from the sun. Other gases, such as we can have the last column, we have other gases such as ozone, we have a gas called ozone. Then we have also water vapor. So this is water vapor. This is a particular, it is water, but it is existing in, water vapor is existing in a gaseous form. It is water that has changed. It is started from solid, liquid to gas. And we have argon. Yes, so we have other gases such as ozone, water vapor, and argon. We want to know what percentage is it present in air. We are told is 0.97%. So we are saying these other three gases, that is the ozone gas, the water vapor, and ozone, they comprise all together, they comprise 0.97%. And we are asking, what are their uses? Many uses of these gases. For instance, when we talk of ozone layer, it is a very thin layer, but the ozone layer is very important. It protects human beings' skin from ultraviolet rays. We have rays that come from the sun. We call such a rays ultraviolet rays. So ozone layer, this is a layer that very thin. It is covering the earth. It's very minute, but it is there. It protects human beings from developing skin cancer. Skin cancer can develop if the ultraviolet rays that comes from the sun are able to get the ozone layer that has been depleted, that has been destroyed by human activities. Human activities can go to the extent of causing pollution and destroying the ozone layer. So if the ozone layer is destroyed, then ultraviolet rays will penetrate through the ozone layer because it has been depleted, and then human beings, the skin, they will be the skin of human beings, they will get damaged by contracting what we call skin cancer. Therefore, maybe we can, right, we have identified the ozone layer, the water vapor, and another gas called argon. We can say there are many uses depending on the gas. The ozone shields human beings from ultraviolet rays. That is ozone layer. Shields human beings from ultraviolet rays from the sun. Therefore, we are saying that ozone layer is there. The ozone gas is there to shield human beings from ultraviolet rays from the sun. So once this ozone layer is depleted is when we can contract skin cancer and so forth. And what about water vapor? Water vapor is part of water cycle that, water comes up when we burn trees. The water goes to the clouds. It can be able again to condense and form clouds again and rain. So the water vapor is there. It's just trying to complete the water cycle that it can go, formulate clouds and rain again and enable plants to grow well. That's the water cycle. And when we talk of argon gas is used in lighting bulbs. When you talk of argon gas, that one is used for lighting bulbs. It's a gas that lighting bulbs. Therefore, we have seen that in essence that air as a natural gas comprises of these close gases. We have nitrogen gas that is present in abundance, that is 78%, followed by oxygen, which is 21%. Then we have carbon dioxide, which is 0.03%, and it's very important and essential is essentially used by plants to make food and so forth. Then we have other gases like ozone, argon, and water vapor. And we have seen their importance as far as supporting human life or living things. We can now proceed and see air as a renewable resource. We have seen what percentages is this air, these gases, we know that also, we had talked of smoke being there, smoke and dust. These are just particles that can be rushed in when we have cyclones and we have storms. They can try to mix some things and you find that air is not all that pure. But we're talking about the pure components of air as a natural resource. So we want to see air as a renewable resource. We are saying our air cannot be depleted. It is not a non-renewable resource. We are saying air is a renewable resource. So air is a renewable resource, and we are saying that air as a renewable resource we are saying air as a renewable resource. We have seen that 21% of air, 21% is oxygen, that's part of the air. 21% of air is oxygen. Oxygen constantly is being used by animals, and at the same time, it is being produced by plants and it is being replaced by plants. So we can see that oxygen as part of gas that is found in air, it is being used by animals, but at the same time is being replaced by plants. We are saying green plants use energy from the sun, from the sunlight, carbon dioxide, and water to make their own food. And when they are making their own food, oxygen comes out as a byproduct while green plants are making their own food. Through the process we call photosynthesis. The production allows oxygen back in the atmosphere, yes, to stay in the atmosphere, to balance the atmosphere at the same level. Because you know that animals are using oxygen, but at the same time the plants now are replacing that particular oxygen again in the atmosphere. So we we normally describe this movement of materials from one place to another and back again as a cycle. So we can talk of oxygen cycle. We are saying that oxygen can go back to atmosphere and then be trapped from that atmosphere by animals or living things, and then these living things, when they trap it, and then the same oxygen is produced again by plants. We talk of whereby these cycles, when scientists describe this movement of materials from one place to another and back again as a cycle. Oxygen cycles is oxygen cycle through the Earth's atmosphere. Oxygen goes through soil, oxygen goes through rocks, oxygen goes through water, and oxygen goes also through living organisms, and then it goes back to the atmosphere. We termed it as a cycle. We are talking of atmosphere. What is an atmosphere? Atmosphere is a very thin layer of air around the Earth's surface. We are saying if we have Earth, Earth is being surrounded by a thin layer of atmosphere. This thin layer comprises of air, comprises of gases, including the ozone gas that is able to shield human beings from the dangerous ultraviolet rays. That's the atmosphere. And we are saying that when we are talking about this renewable source, we have identified oxygen as a renewable. Oxygen is a gas. We have said oxygen is a renewable source. It is a renewable source because of the way living things use oxygen, and plants are there also to manufacture the same oxygen to replace. When we come to carbon dioxide, we say carbon dioxide is a renewable source because it is produced by living things, human beings and animals, carbon dioxide, but it is used up by plants, but released back to atmosphere by human beings. We are saying oxygen is a renewable gas. We are also saying carbon dioxide is a renewable gas, and it is present, it is 0.03 of air, 0.3% of air is carbon. So 0.03% of air is carbon dioxide. This is enough to supply all the green plants with it is enough to supply all the green plants with the carbon dioxide that they are required to have, so as they can produce their own food and carry out that process called photosynthesis. Now, we are saying animals breathe out carbon dioxide because it is a waste product after the process of releasing energy in their bodies. So carbon dioxide is also being replaced in the air by animals, being used by plants from the air and then being replaced back in the air by animals. So we can say that even carbon dioxide, there is what we call a cycle, carbon dioxide cycle. It goes on to atmosphere, back to the living organisms, to plants, and so forth. So we are saying it is part of the cycle where the gas goes to atmosphere and then it goes back to the plants and so forth. The cycle of oxygen and carbon dioxide, we can be able to depict that one, how the cycle of oxygen and carbon dioxide can be shown in the symbol diagram below to show how carbon dioxide goes back to atmosphere and so forth. We can have plants producing oxygen, can have a symbol diagram of plants producing oxygen, then we can have an arrow, animals takes in oxygen. Then down here, we can have plants producing oxygen. We shall have a plant there. We can have our animal here. We hope we can have a slight structure of an animal. We can say it's an animal. So we can say this is a form of an animal. We can have here animal releases. Animals releases carbon dioxide. Yes, carbon dioxide. So the animals releasing carbon dioxide, and then plants take in carbon dioxide. Plants takes in carbon dioxide. Then we can plants take in carbon dioxide. Plants uses carbon dioxide to make sugar. To make sugar. Then we can have this one as part of the trees, and yes, we can have this one as representing a tree. This one can be a tree trunk. Then, so the plant is producing oxygen, an animal is producing carbon dioxide. Plants take in carbon dioxide. Plant uses carbon dioxide, yes. Animal releasing carbon dioxide, and that carbon dioxide is being used. What this diagram is simply showing is the cycle of oxygen and carbon dioxide. This is the cycle of oxygen and carbon dioxide. Therefore, through this symbol diagram, we can be able to show the cycle of carbon dioxide and oxygen gas. We had named these two particular gases. We have said they are renewable. They are renewable because once the animals and human beings, they are able to use oxygen, and carbon dioxide comes out as a result of a byproduct, and find plants taking in this carbon dioxide that has been released in the atmosphere in the process of photosynthesis by making their own food and releasing oxygen that is used by human beings. So the human beings, they release carbon dioxide to the atmosphere. Plants also release carbon dioxide to the atmosphere. We can see that human beings depend on the plant for the oxygen, and the plants are depending upon the human beings also to get carbon dioxide gas. When we check this gas, the carbon dioxide gas, it exists in the same level of 0.03. It's enough to be used by the plants to manufacture their own food and so forth, and so forth, to manufacture sugar and so forth. And the same oxygen, 21% of air that is available as oxygen, also is enough for the human beings and other living organisms to use. So this is a life cycle, how the oxygen and the gas goes to living things, and back to the atmosphere. So we are saying the exchange of oxygen and carbon dioxide between plants and animals renews these gases in the atmosphere. The gases are ever renewed through the plants and animals. The most abundant gas in the air is nitrogen. Nitrogen is the most abundant gas in the air. It is available it is 78%. Nitrogen has also its own cycle. It is absorbed by some organisms and released by other organisms. Those who have known what happens, or maybe we can talk of lightning. Lightning, whenever there is a thunder and lightning, sometimes this nitrogen gas is brought down, is fixed in soil. But apart from that, we have nitrogen fixing bacteria. They are able to trap nitrogen from the atmosphere and fix it within the soil, this nitrogen fixing bacteria. We also have bacteria that are able to remove the nitrogen also from the soils back to atmosphere. So we are saying nitrogen is important as far as the manufacture of food are concerned within the living things and so forth. But we are saying nitrogen is available in abundance percentage in air. Air comprises is made up of most of this nitrogen gas. So let us now, we have checked how gas is. We have seen the contents, the components of air. We have seen the nitrogen, their level. We have seen the structure showing even the importance of ozone layer, how it protects human beings, skin from cancer and so forth. Now, can we see sunlight as a resource? And we are saying, when we are talking about sunlight as a resource, we say sunlight is a renewable resource. As long as the sun rises and it shines, then we have the light, and the light will be used by plants. So let us see sunlight as a renewable resource, what this sunlight does to living things and living organisms. So when we see sunlight as a resource, we are saying sunlight is essential for life on Earth. This is because of the following reasons. So sunlight as a resource. One, we have said sunlight is essential for life on Earth because of the following. One, plants. Reason, the most important reason is plants. Plants use sunlight to produce food. So for plants, plants use sunlight to produce food. They are able to trap this sunlight and they use it as a form of energy to make their own food. So sunlight is very important, that's one. Plants use sunlight to produce food. That is the first point that we can mention. But the second point we can say, sunlight warms the Earth's atmosphere. Sunlight warms the Earth's atmosphere. So it's not only atmosphere that is kept warm, no, even land. Land is warm, water is warm. It keeps water in a correct temperature so that water can stay in a liquid state. We are saying if there was no sunlight so that it could maintain the correct temperature, then we will have seen the water that is existing within around the Earth. This water will have frozen, will have changed into a solid state. And that's dangerous because even the organisms within them, they contain water. And the water that is contained within the living organisms can also freeze. And if it freezes, then that particular living organisms will not continue to be alive. So we are saying that sunlight warms the Earth's atmosphere. We are saying sunlight warms the Earth's atmosphere, and we are saying with the correct temperature that is maintained, with the correct temperature that is maintained, that correct temperature that is maintained, then there's no freezing, there is life. There's life. There are animals that cannot exist under particular temperatures. Temperatures can be dangerous. So we are saying living organisms contain a lot of water, so they might freeze if there was no sunlight. So sunlight as a renewable resource. We have just seen sunlight as a resource, but now we are seeing sunlight as a renewable resource. As a renewable resource, this is the information we can pass forward. Sunlight is a renewable resource, and it will be as long as the sun keeps on shining. We are saying that sunlight is a renewable resource. As long as the sun keeps on rising and shining. The sun is a star, that is one of the stars, and it will continue to shine for billions and billions of years. So there are no occasions we can think of losing sunlight. We are saying sunlight is a renewable resource. As long as it keeps on rising and shining, it will be able to provide. So it's a renewable resource. We can now, we have already identified why sunlight is very important. And we know for the growth of particular plants, they require particular temperatures for them to grow. So the importance sun is very vital. So the importance of sunlight, we cannot just brush it out. For any life to be supported here on Earth, on the atmosphere, the sun plays a very important role. So we know. Then we can advance ahead and see water as a resource. We have seen sunlight as a resource. Now we can advance ahead and see water as a resource. Now, when we talk of water as a resource, we again say water is available in plenty. When you look, most of the earth surface is occupied by water. Water covers most of the earth's surface, and all living things need it to survive. We cannot talk of any organisms that can live without water for a long period. In fact, even that particular living organisms, for it to be alive, then within it there must be water. For instance, if we're talking about human beings, we are told human beings, the percentage is close to 70% of what human beings are made of is water. So when we talk of we remove water, then we will not be there. So water is very, very essential and very important. So I say no organism can live without water for long. For this reason, water is the most important resource. For this reason, we are saying water is the most important resource. Those who have known scientists, whenever they want to trace whether a planet has life or whatever, whether they want to tour, whether it is, that we have Mars. If they go to Mars or they go to Moon, the scientists would like to know, these other planets, do they have water? If there is any presence of water on any planet, then it signifies that that particular planet supports life. So water is indeed life. Those who know, if you go to the components and elements of water, it has hydrogen and oxygen. Okay, so we are saying that water is the most important resource. Then we are saying this most important resource, which is water, water is a renewable resource. We are saying water is a renewable resource. We have seen sunlight as a renewable resource. It is renewable because as long as the sun keeps on shining, and then rising and shining, then you have sunlight. But we are saying water is a renewable resource. Water is a renewable resource. Water as a renewable, it is a renewable resource because it can move from one place to another and replenish an area. It has a cycle. Only a teeny fraction of water on Earth is made new each day. Only a teeny, but most of it is there. Only a teeny part of the fraction of water is made new each day. Some water is made whenever, point number one, living things like trees burn. We want to know, how is this water made? Where is it coming from? we had said all living organisms contain water. If we burn these organisms that have water in them, and the water exists in this living organism in a liquid state. So when you burn these living organism will die. But the water that is contained in this living organism will change into water vapor. So we can see it has changed into water vapor, and then after changing it to water vapor, it will go to a higher level where it can condense and form clouds, and again fall down as form of rain. So we're saying water is made whenever, water as a renewable resource is made whenever, point number one, whenever living things like trees burn. Living things like trees. So when we are burning living things like trees, when they are burning, we can think that we are destroying trees and we are destroying water. Water is only changing its state from a liquid state that it used to be present in trees, and it changes into water vapor. So when we burn living things like trees, when they burn, then we are making water. Water will change into water vapor, it will become clouds and so forth. Also, fossil fuel like petrol and coal burn. When we burn fossil fuel, like petrol, coal, when we burn, we are burning them, yes, we burn, we are also getting water. When you burn fossil fuel like petrol, so whenever they burn, also water is formed. Then the last point, we also get water when living things release energy in their bodies. Living things release energy in their bodies. The simplest example is you might find somebody sweating. Why are you sweating? If you look sweat, you will find these are droplets of water. So energy is being released. So we are saying when living things release energy in their bodies, then we shall have water also being released in the form of sweat and so forth. So we are saying the total amount of water on Earth is thought not to have changed much since the planet was formed. So what we are saying is the percentage of water that has been there since the creation of the planet looks to be similar. There has not been any change altogether, any drastic change in the form of the percentage of water. We shall have some few revision questions, and then we shall proceed on to tackle rocks. We got rocks. Rocks are also, it is a resource. The rock itself is a resource, but from the rocks you can have two kinds of resources. So we are saying some of the questions we can have for revision of some of the topics were covered. Question number one, list the major natural resources on Earth. That is the question number one. Question number one, list the major natural resources on Earth. That is the first question. The second question we shall attempt to answer is list 10 made resources that help humans to survive. List 10 made resources. List 10 made resources that help human beings to survive. Then define the term, what is a resource? What is a resource? Any substance that is needed by human beings or living organisms for their existence. That is a resource. Explain, another question, explain why living things can be considered renewable. Let me repeat, explain why living things can, explain why it is important to conserve non-renewable resources. Explain why it is important to conserve some renewable resources. Let us start by tackling the first. List the major natural resources on Earth. The major natural resources, if you had listened to the earlier topic and the continuing topic, we said the major natural resources are, one, we had identified air. We said air is a natural resource. We also identify another major natural resource as water. We said water is a natural resource. We also identified sunlight as a natural resource, one of the major natural resource. And we also, apart from, we identified sunlight, and we also identified another natural resource. We identified salts, rocks. Rocks, we know with rocks there are many. It's also another natural resource. Rocks are there. From rocks we can get soils and other important minerals. And on the so the major natural resources that we have air, water, sunlight, rocks, and we have living organisms. We had said that living organisms, because they can also reproduce. They are a natural resource, of course, but they are also renewable. So we have living organisms. Now, when we came to the second question, list 10 made resources that help human beings to survive. Well, human beings are surviving, but they need to survive more comfortably. And we said these made resources will increase as much as we have technology. With advancement of technology, we shall keep on increasing and discovering other made resources that will keep the life of human beings on Earth more comfortable. Now, some of the made resources that were identified, we started with one, those who can remember, we said food. And we said an apple is food, but there's no single activity that human beings have done to this particular apple or orange. So if you take just an apple as food, we cannot call that apple or an orange as a made resource. That one is a natural resource because we have plucked it the way, right from the way it has, from the way the plants have produced it. So we are saying, but if we make some changes, for instance, if you take wheat and you are able to make bread from wheat, now this bread that you are able to make, it's food, yes, that one becomes a made resources. You are able to make bread from wheat and other plant products. Also, we had said another example is leather. We are able to make leather from a natural resource called skin and hides. So when we take skin and hide, that's a natural resource. It is not a made resource, but it becomes a made resource when we come up and produce leather. And you know what we can use leather for. Another made resources, we said, there are plastics. When you have plastics and synthetic fibers, which the polyesters, which we can make from oil. From oil, we can be able to make the plastics and other synthetic fibers and so forth. So these plastics and the synthetic fibers are what we are terming as man-made resources. And then we have fuels like petrol, diesel, kerosene, and so forth. Those are made resources because we are able to extract them from oil. Then we have metals such as iron, aluminum, and so forth. These metals such as iron, aluminum, they are made resources. Yes, we have extracted them from metals, but we are able to have our aluminium, and we know the many different things we can use aluminium for. If we are talking about iron, we know what we can use iron for, apart from building bridges, building houses, and many things, building car parts, bodies, and so forth. So iron can be used for a number of things, and we are saying it is a made resources. The natural resource, it was a rock. The natural resource, it was a metal. But from that metal, we are able to extract the iron that we want to use for. Also, another made resources, we identified the ceramic such as the bricks, porcelain, and so forth. So we are able to make them maybe from clay and so forth. So it is a made resource. We also identified cement. When we have cement, we are able to extract cement from limestones and so forth. So limestone is a natural resource, but when we come to cement, it is a made resource because it has costed us some experience, some activity, so that some expertise to come up with cements and so forth. Then lastly, we also mentioned when it comes to made resources, we mentioned medicine. We said we can extract medicine from plants. We can also extract medicine from animals. We can also extract medicine from minerals. Yes, minerals are there, but at their natural state, they are not medicine. What is a medicine? It is something that you can take maybe if you are sick so that you can regain your health, you can regain your status, you can be able to get healed. So medicine is a form of drug. These are drugs that can be able to heal you. So we are saying by coming up with medicine, medicine is a made resources because we have made medicine from plants, we have made medicine from animals and from minerals. And we are saying that is okay. We have given an example of how we can respond to these questions whenever we are asked to respond. Now we can continue with rocks. Rocks as a resource. Rocks are a resource, but rocks as a resource, we can divide rocks as a resource into two. The rocks themselves, the way they are a resource. You can cut them, the ones that are hard, you use them for building and so forth. And again, we can have those rocks, but we are interested with the minerals. That minerals that are present within those rocks is what we want to use as a resource. Therefore, we can see rocks as a resource. Now, we have said that rocks as a resource, we say rocks provide two different resources. We have said rocks provide two different resources. The first resource is the rocks themselves. So we are saying rocks themselves as they are a resource. You can cut them, you can use them for building, those that are hard ones. So you are interested to pick the rocks as they are. They are hard, they are tough, and you are not interested in anything else. You are just interested in rocks as they are. Maybe you want to use them for construction and purposes and so forth. Then minerals found in them. Then there are also in another resource, rocks. We are interested in rocks because of the minerals found in them. So the minerals that are found in rocks. Yes, we have rocks, but we are just not interested in rocks per se. We are interested in what is contained in these particular rocks. So we are saying there are many different types of rocks. We need to know that. There are many different types of rocks, and some are hard and can be used without altering them. They can be used the way they are. They are hard and they can be used without altering them or removing any material from them. So in case you want to use rocks and they are hard and you want to use them for construction, maybe you just want to use them the way they are without changing their state whatsoever. These rocks are used mainly for roads. In terms when we are constructing roads and buildings, we shall use the rocks the way they are. So rocks the way they are a resource. We can use them for constructing roads, we can use the rocks the way they are when we are constructing buildings. So that's okay. We have other rocks that are soft, like limestone and sandstone. They are soft. So these rocks can they can easily be cut, and they can be used for paving walls and so forth in paving. So there are other rocks that are very soft. They can be used for a number of things. Then there are rocks. Rocks are made from substances called minerals. Rocks are not just rocks per se. There are things that make up these rocks. So we are saying rocks are made from substances called minerals. Minerals differ in their physical and properties such as color and hardness. So we are saying the minerals that make up these rocks, these minerals differ in terms of color, in the physical formation, in terms of, they differ physically in terms of color. They also differ in terms of hardness. Others are soft, others are hard. So we are saying many minerals are important resources for human beings. I repeat, I'm saying many minerals that are found within rocks are important to human beings. A variety of minerals and their uses are as follows. We are going to have a table trying to show the particular minerals that are present in particular rocks and their importance, what particular purpose they serve to human beings. So we can have a slide table showing the minerals and their main use. Therefore, we are seeing the part 2. We had said that we are interested in rocks themselves the way they are. We can use them for buildings of rocks, building buildings and so forth. But now when we are interested with rocks because of the minerals that are contained in, then these minerals are essentials and they play important activity. They're important in human life. They are used for this particular purpose. So we can have a small table where we have the minerals. We can have a table for a mineral, and then we can have main use. What are they used for? Main use. Then we can identify the first metal, bauxite. The bauxite. Now the bauxite, this kind of mineral, it contains aluminium. We can have our table like so. We can be disciplined to, so I say it contains aluminium. When we say bauxite contains aluminium, we are saying aluminium is used in making aircraft, drinkers, and high voltage power lines. So we are saying bauxite, these minerals that is in rocks, it contains aluminium, and we are saying aluminium is used in making aircraft. We have aircraft, and then we also have drink cans, and we also have high voltage power lines. Now that one, it acts on electricity. So we are saying that this particular mineral is important because this particular mineral, it contains aluminium, and we have seen what the importance of aluminium. Therefore, and also we can mention the second hematite. Yes, hematite. Hematite. This particular mineral, hematite, this particular, it contains iron, and we are interested with iron. It contains iron. What is iron used for? We are told iron is used to make steel. Is used to make steel. Yes, iron is used to make steel, which is used in car bodies. Used in car bodies. Yes, which is used in car bodies, nails, ships, and bridges. Nails, ships, and bridges. We cannot underestimate the importance of iron. So iron is very important as far as making car bodies, nails, ships, and bridges, and so forth. Another mineral is called malachite. Malachite, this is another mineral. It contains copper. It contains copper, malachite, and we know what copper is used for. Copper is used for, it is used in electric wiring. Copper is used for electrical wiring. So electrical wiring, so we know the importance of copper as far as wiring is concerned. Then the last mineral we shall check here is halite. Halite. Now this metal halite, it contains sodium chloride. It contains sodium chloride. Sodium chloride is table salt, and we know how table salt is important as far as cooking is concerned. Whenever we are cooking food and so forth, we can use this table salt to add flavor and so forth. So table salt is important. So we are saying sodium chloride is used in food preparation and medical applications. So it is important. So we can find this mineral called halite is quite important. This is an example of how rocks are important. We had said that rocks are important as rocks themselves, the way they are. And when we are talking about those rocks that are hard, we shall cut and use them the way they are in buildings or construction of roads and so forth. But the second interest with rocks as a resource, we said we are interested in rocks as far as the minerals that make them up. Rocks are made from substances called minerals, and we have identified some minerals, the ones we have listed here, that are important. We use aluminium, it's a mineral. We use it to make the aircraft wings and so forth. We have iron, we use it to make nails and so forth. Therefore, as we finished, we are seeing that rocks are some of the minerals that are needed by living things. Rocks gradually break down, they release minerals which end up in water, oceans, and so forth. We are saying these rocks are very important as far as human beings are concerned. We shall come and proceed in our next topic. We shall see how rocks is a non-renewable resource. Once rocks are used and they are depleted, we cannot bring them back. There is a process of formulating rocks. Some rocks go through a process called metamorphosis, and we get metamorphosis rocks. Some rocks are formed from the magma that spill over from the earth crust. They come up, a magma process, and they cool down in lava, and we get rocks called igneous rocks. Some rocks break down and they are taken away by water to the ocean banks and so forth. These sediments that are broken down, they form up rocks called sedimentary. We shall come and observe how these sedimentary rocks, igneous rocks that those cool beneath the ground, those lava that is able to penetrate and they cool on the surface, how they cool very fast and they formulate rocks, how they are important. So we shall come and continue how rocks are non-renewable. We need to use them well because once we deplete them, we cannot get them back. It can take millions and thousands of years to get them again. So we can stop there for now. In our next lesson, we shall pick on rocks as a non-renewable resource. Remember with the water, we were saying water is a renewable resource. We had said sunlight is a renewable resource, even air. But now we are seeing rocks, we are saying rocks are not renewable resource, they are non-renewable resource. Thank you.